Hello, my name is Bruce Devlin, and welcome to the Dalet Academy BPM webinar replay. You might have seen this webinar live, or you might not have seen it live. Either way, what you need to know is that our webinars are available from the Dalet Academy at academy.dalet.com, and we do one every 4 to 6 weeks on an interesting topic that you'll find in the media industry. I'm Bruce Devlin. I'm the Chief Media Scientist here at Dalet, and along with the webinars that we produce, we also have a series of educational blogs, educational videos, and other resources that help you understand the complex and transitional world of media engineering. All of it's free, so go to academy.dalet.com and sign up for the various resources that we have there, and I hope you enjoy learning about some of the technology that's available to you in our industry. If you have any ideas for any of the Bruce's Shorts videos or a blog post or a webinar idea that we can help you learn from, then please drop us an email to academy@dalet.com and we'd be more than happy to add it to our wish list of things that we will talk to you about. So what is this webinar? Well, performing this webinar is the presenter's function. My job function is to talk to you and give you education. The service that this webinar provides is to educate you on the terminologies of service-oriented architecture, business process management, and web services. The service this webinar provides will help you use that vocabulary that you learn to use, procure, and configure products and systems. It'll allow you to break down business problems by the services that are required to solve that problem and the processes you need to implement and manage to implement those services. Hopefully it will also show you how to use those tools in an efficient and automated way. So although my job function is to do this webinar, the webinar itself is providing you a service. In fact, it's the BPM education service. Now, you could have learned everything I'm about to say from a book or by Googling or reading Wikipedia or other websites. So the BPM education service can be implemented in multiple ways. It can be implemented by this webinar or a book or Wikipedia or any other delivery medium. It's also reusable because you're watching the replay. You might have watched it live, you might not have done, but the content is reusable and can be given to you multiple times over and over again. Not only that, but it's discoverable, because if you hadn't discovered it, you wouldn't be sitting here listening to it. So already we're looking at the difference between functions and services, and we're going to explore that in more depth as we go through this webinar to help you understand the difference between functions and services so that you can figure out how they apply to your business. There are other BPM resources available from Dalet and others. In addition to searching Google, you may have seen a shorter version of this webinar that I presented at NAB 2015. We've got several blog posts on the topic of BPM, and if you enter that search URL into a browser, you should end up with several of our blog posts talking about the theory and strategic thoughts you can have on business process management, as well as some of the technologies like BPMN, business process modeling notation. And if you buy any of our products, of course, you'll find that there's BPM technology buried within them. So what are we going to do today? We're going to start off by looking at the basics of service-oriented architectures. Then we're going to look at business process management, look at the basics of web services. We're then going to put it all together in a couple of workflows, and then explore the difference between a high-level workflow and a low-level process flow, and why that might be important in designing your business processes. Then we'll see whether or not you should really care about BPM and SOA, and there won't be any Q&A because this is the replay, but who knows, I might just make up a couple of questions that were asked during the live versions. So let's kick off. SOA, Service-Oriented Architecture. It's not a technology, it's a way of thinking. You can't go down to the shops and buy a kilo of SOA. It's a way of thinking about problems so that you can find solutions to those problems. SOA has evolved because many people over the years have been thinking about designing for change. And designing for change means that you do the work once And as your business changes, you get more benefit from the work that you've already done. So why do things change? Well, your business is never static. Your business is continually changing. You're not an isolated case of one company doing things with media. You work in a whole environment and ecosystem of people trading media around the world. You get new knowledge. It's not quite the same as wisdom, but you learn more about how your business works. You figure out who are the good and easy customers to deal with and who are the difficult customers to deal with. You work out how you make money on certain deals and how you might lose money on other deals. So gaining that knowledge and wisdom and learning over time gives you the ability to change your business processes to either be more responsive or more efficient, or maybe just not do things to make your business effective. And the external world will continue to change. In media, we're in the process of huge flux at the moment, as there are new delivery channels appearing and different businesses starting up trying to take advantage of those delivery channels. The viewers have more and more ways of consuming content and more devices on which to do so. But the actual revenue per eyeball contact second is probably going down over most distribution media. And to cope with that, there's massive change going on all the way from the camera all the way to the TV set. But don't forget, even in a static business, with nothing changing externally, you still have internal changes. That bright girl that has all the fantastic ideas about the way that your software works, well, if she leaves, suddenly you've got to try and fill that gap, and you'll never fill that human resource identically with the person who has the same ideas. You'll have to change your processes to adapt to the staff that you've got, to match your skill set against the processes that are being done within your organization. And you might even have to have multiple versions of the same service. Think about it. You're watching this webinar over the internet. You probably have more than one data delivery service coming into your building. You might have fiber and ADSL, so that if the fiber disappears, the ADSL can take over. That redundancy is important to your business, because the video player playing back this webinar, it doesn't care whether the bits came to you over ADSL or fiber. All it cares is that the bits came over in the right order, in the right packets. So by layering your services correctly, you can build in redundancy so that when there is a change, like some emergency takes place, you can seamlessly cover those changes. And it also makes sense when you're upgrading. When software changes, it can have unintended consequences, because a programmer doesn't know how your business works. They just know the functions that their software should perform and the services those functions should deliver. And if you build your systems right, you should be able to have multiple versions of the same service, delivering the content so that you can shadow one against the other and predict what the changes are going to be before those changes have an impact upon your business. So let's have a look at the difference between services and functions. Well, as we've already discovered, a function is what you do and how you do it, whereas the service is the benefit that that function brings and the value it adds to the business. So let's have a look at an example. Look at this fine chap, handsome looking man, even though his shirt doesn't seem to fit over his belly. His job function is the tape delivery boy. So what he does every day is he delivers tapes from A to B. And if you need to have a bit more capacity within your job function, you simply hire more tape delivery boys. That's fantastic. But actually, the service that that job function provides to the business is to move media from one place to the other. So the tape delivery job function is actually the media movement service. Or in fact, the value that the tape delivery boy brings is to move media from one place to the other. And this is important because if there's a technology change within your business and you no longer have to shift tapes, but instead you're moving files around the place, the correct interfaces into the media movement service don't have to change between the job function of moving tapes or automated function of moving files, regardless of whether you're using FTP or one of these proprietary solutions. To have the interfaces to the service correctly defined allows you to automate a particular implementation of that service. So the tape delivery boy is one implementation of the media movement service. The Signiant file mover is another implementation of that media movement service. And Aspera is yet another implementation of that same media movement service. And if you define the different services that your business requires correctly, you should be able to plug them together without having to change any of the properties of the interfaces. So it doesn't matter whether the ID of the media identifies a tape, or the ID identifies a file, or the ID identifies some other physical incarnation of your content. If you define your service correctly, putting the media ID into your media movement service will cause that media to be moved from a location to another location. So let's have a look at some good properties of services, because if we define our services correctly, it looks like we can get some good value. So one of the good properties of a service is loose coupling. What does that mean? Well, basically we're trying to figure out, is the service dependent on its implementation? So if I defined my service as a human tape delivery service, that's the movement of the media is tightly coupled to the way that the media is moved. But if I call it a generic media movement service, then actually I can have several implementations, not all of them equal, not all of them able to move every single asset, but at least I can have a variety of different media movement services that are able to cover the total requirements of my business, and I can talk to them all the same way. For example, the data on a D3 tape is tightly coupled to the signal on the D3 tape. The only sort of data that you'll find on a D3 tape is composite video, modulated in a specific way and striped on the tape in a specific way. But an LTO tape, the data on it is very loosely coupled with the tape. I can store all sorts of things on an LTO tape. I can store JPEGs, I can store text, I can store all manner of versatile things, because the LTO tape, the format of the data, is loosely coupled to the tape, not tightly coupled as in the case of the D3 tape. Another good property of a service is statelessness. In other words, does the interaction with the service depend on what state it's in? Well, what does that really mean? It's all to do with, do you have to remember any state of the conversation in order to have the conversation? Let's do this by example, because it's easier. Here's an example of a stateful conversation between two servers. Server A says, "Hello, what's your name?" Server B replies, "Mr." Server A says, "Hello, what's your name?" Server B says, "John." Server A says, "Hello, what's your name?" Server B says, "Smith." Server A says, "Hello, what's your name?" Server B says, "End of transmission." Now, if you're over 40, that might look sensible and logical. And if you're under 30, it might look crazy. And that's because once upon a time, communications bandwidth was extraordinarily expensive and memory was extraordinarily expensive, and so all sorts of stateful conversation mechanisms were implemented in all sorts of different protocols to save bandwidth and to save memory. However, what you got in exchange for saving that memory and bandwidth was horrific complexity and all sorts of ways in which systems could fail. It's much simpler to have what's known as a stateless interface. A stateless interface means it doesn't matter how or when you ask the question, you always get the same answer to the same question. So, "Hello, what's your name?" You get the answer, "Mr. John Smith." "Hello, what's your name?" "Mr. John Smith." "Hello, what's your name?" "Mr. John Smith." "Hello, what's your name?" No, actually, it's Mr. John Smith. So the idea of stateless is that for any two given systems, the communications protocol shouldn't depend on the state of the system. You should get the answer you need, the snapshot, by asking the question and getting the full answer wherever possible. That's what's known as a stateless interface. Another good property is abstraction. So good services have general interfaces with specific data. And data is often grouped into different categories to help with that abstraction. So there might be some functional metadata, some technological metadata, some programmatic metadata, some QoS metadata. Why is that important? Well, just think about some of the service interfaces you end up with on a server, for example. If you wanted to query the fan speed of a server, there's an abstract fan speed interface in the, for example, the Windows Management Interface service. It doesn't matter what the make of the fan is, you just query the fan speed and you get the fan speed back. Can you imagine the nightmare if each individual manufacturer of each fan had their own proprietary API, so that you had to, by some magic, know the brand of fan in your server before you could query the speed? That would be crazy. That would be much like the way the media industry is today, in having a different proprietary interface for just about every playout server, every transcoder, every rendering engine, and all the other proprietary devices we have in our industry. So, in a way, by not having these generalized abstract layers, we make life pretty difficult for ourselves. One organization that's looking at abstraction is the FIMS group. So FIMS are looking at how you abstract and how you generalize the interfaces to media equipment. So they've got these common data types. If you like, this is a vocabulary for talking to any FIMS compliant device or any FIMS compliant implementation. It doesn't matter whether you're querying a movement service or an object store or a transcode store, it's always going to be the same format of dialogue, regardless of whether you're querying errors or looking for resource descriptions or protocol descriptions or querying a video format. There's one vocabulary that works across all the different media devices. And it's that sort of abstraction which allows you to get scale. And once you have scale, you end up with good cost benefits, because the vendors want to do it because it's less work, and the users want to do it because there's a much better chance that the results are actually going to work. So the implementation and description of any particular service is independent of the actual media or its implementation. So you get this abstraction, this way of stepping back from the problem. Another good property of services is autonomy. So if the service can look after itself, if it can control its own execution and destiny, it will be more predictable. There's been lots of experiments over time, and search the internet and read Wikipedia on this particular topic. But the grand central control theory of I will run all of my services and I will keep everything in check doesn't tend to work very well over time, because there are too many variables. So giving the service the autonomy to start itself, stop itself, execute where required, and communicate as required is more likely to be successful for you. And when you start to communicate and pull different services together, trying to keep the service autonomous helps prevent deadlocks and helps prevent interoperability problems. And this autonomy goes hand in hand with loose coupling. Loose coupling gives you that lighter touch and gives you a greater chance of efficiency and success. Another good property of a service is reusability. It seems obvious that you want to reuse services to get better return on investment. So if you're using an ingest service to ingest your material, it'd be nice to use a transfer service to then bring that material to where you need it. For an archive service, wouldn't it be good to use the same transfer service to push the material in and out of the archive? If you're replicating between sites, wouldn't it be the same thing there to use the same transfer service to push and pull material to other sites? And if you're publishing for OTT or off to a playout site, wouldn't it be good to use exactly the same transfer service? Because actually, if you reuse that transfer service in all of these different applications, you start to become familiar with that transfer service. You're getting better benefits from the learning. You're more likely to find out the faults and the flaws with that transfer service. So by having the one transfer service and reusing it, maybe there might be different implementations of that transfer service, but from a business perspective, you've only got one. That gives you the ability to figure out how you're getting best ROI from that transfer service. And you can start to see which are good implementations and bad implementations because you have enough data points to make realistic comparisons. Another good property is what's known as composability, or maybe decomposability. So big problems that you're trying to solve are composed of smaller problems, and each of those small problems has a smaller solution. So by breaking the big problem down into small bite-sized chunks, you stand a better chance of solving the problem. And by turning those big problems into small, easy to understand, easy to implement, easy to solve as a service problems, you stand a much better chance of having the thing stable and reliable. And that can be shown pretty easily in a big picture. We might start off with some job request coming in, and that job request is to solve a big problem. It's like, make me 75 OTT variants. By splitting that big problem into lots of little small problems, and then mapping those onto some sort of implementation, we stand some good chance of implementing it, monitoring it, and having it autonomous and reusable. So for example, making a VOD asset involves all of these separate process steps. So from a big high-level workflow perspective, what we're trying to do is make a VOD asset. But from a process flow perspective, by splitting that into a smaller number of specialist jobs that sniffs the source, renders the captions, fetches the metadata, transcodes the media, moves to the target, and computes all the hashes, what we've managed to do is map the big problem of making a VOD asset onto a number of separate little small services that we have at our disposal. So that's composability. And in fact, you'll notice that some of those problems have mapped onto the same service with different capabilities. And so my transcode service is able to transcode the captions, it's able to transcode the media, and it's able to compute the hashes. It's able to do those media manipulations that are required to implement the overall fix to the big problem. And don't forget discoverability, because if you can't discover your services, you can't use the services. In most workflows, discoverability starts off with some sort of human discoverability, that the human has to provide some way for the machines to find the service. That might be searching Google for AWS cloud services and then pointing your browser at a different place. And then the more you discover, the more the machines can do their discovery process for you. And for different applications, there are different protocols which have been invented to try and help this service discovery. So Dynamic Host Control Configuration Protocol, DHCP, that's actually one way of discovering configuration services on the network. Bluetooth has a service discovery protocol, and there's a web service discovery protocol as well. So there are machine protocols out there aimed at different application niches. But very often you start off with human ways to discover your services. So if you're buying service-oriented products from people, one of the good questions to ask is, how do I discover what services this box or this software provides? So let's have a look at an example of web services in action. So here we have a thing called a geolocation service. So if I wanted to find out the geolocation of a particular server, for example google.com, I could go to this geolocation service on the net and say, find me the geolocation of an IP address for free of google.com. And this is what I get back. I get this little XML ticket coming back that says google.com resolves to that IP address, and this is where I found the server. And look, it's got some longitude and latitude information. I could now, if I wanted, find out whether the rain is falling on Spain or whether the rain is falling on Google. So I could use this API, and in my query, I give it the latitude and longitude that I found from up here. That should have been a minus, by the way. And I can figure out where I am. I can see that it's partly cloudy. I can find out all sorts of interesting things about the weather for that geolocation. So by chaining these two different services together, I can find out interesting things. And these services are completely independent. They're written by different people on different days, but because they're well-defined services, I can take metadata from one service, plug it into a different service, and add value. So these services are loosely coupled. They're discoverable because I found them on Google. They're autonomous. They don't depend on each other to start and stop. All those good features that I talked about are all exemplified by this particular example. Although it has to be said about this one, too many people are using it, so they're putting in API keys that you have to register for. So if you want to try this example, do it fairly soon before it all changes and disappears. So one of the things about SOA is knowing where your service starts and where your service ends. And very often, the correct definition of the service is dependent on looking at its boundaries. I call this the bounding box problem. What are the inputs to your service and what are the outputs? And often, it's not very well defined. You have choice in your business in defining this. Let's take an example, and this is one from the UK Digital Production Partnership. Once upon a time, this fine fellow here would deliver tapes from the post house to the broadcaster. There we go. You get a QC mark where somebody would QC the tape. And then this fine fellow would deliver the tape from A to B, leaving the QC report behind. Oh, that's not very nice. And then somebody at the broadcaster would redo the QC to check that the tape had not been damaged in transit. And because you had to check the tape had not been damaged in transit, very often you would go and redo all the QC that you'd just done in the post house. Well, that seems nuts, doesn't it? So what happens when you now move to a more reliable system where you can do checksums of the file before it sends and guarantee that there's been nothing lost during the transmission? Well, if you're doing that, why on earth would you redo the QC that had been done at the post house? You'd surely want that information, wouldn't you? And that's exactly what's happened now that the DPP has delivered for the UK a file delivery protocol and specification. The QC is done at the post house, and then the QC report and the file both travel to the broadcaster, and the work is not redone a second time. What's actually happened there is you've modified a commercial relationship between the post house and the broadcaster. By changing the technology to better reflect a good business practice, you've ended up with a different commercial relationship between the two sides. And in fact, if you think about what we're trying to achieve by good service-oriented architectures and good business process management definitions, we're definitively trying to affect the commercial outcomes because we're trying to save money and we're trying to only do things that add value and not do things that don't add value. So this is a very good example of how the broadcaster here can win because they don't now have to do a job that's already being done by the post house. What they're paying for is the delivery of a file that meets their broadcasting standards. And they're trusting the post house to do the QC to prove that. Now, whether or not this was a good commercial example from the post house's point of view, I leave it to phone up your favorite post house in the UK and ask them. But I think as time goes on, we'll see more and more of these business relationships changing as a result of better and more sophisticated business-oriented software appearing all the way through our industry. So that was service-oriented architecture, where we've been looking at the principles of service orientation. Now let's have a look at the BPM, Business Process Management. So SOA is a way of thinking. BPM is not a technology, it's a methodology. You can't go and buy a bucket of BPM, but you can learn the methodology of BPM and you can buy processes and manage them using BPM. So what's a process? What specifically is a business process? Well, a business process is a set of actions performed by systems and or humans to achieve a business goal. That's good. I think that's easy to understand. So what's business process management? Well, it's a methodology for managing multiple business processes. Oh, that's interesting, because if you look at the previous side, the process is all about achieving a business goal. It doesn't say use this technology because it's fun. What it says is I'm trying to achieve a business goal, and then my business process management is a way or a methodology of managing those processes to achieve the business goal. And if I keep saying the word business goal often enough, you'll get the idea that what we're trying to do here is change the way that we do business to be more efficient, to do things that add value to our business, and preferably not do things that don't add value, if a double negative's not too complicated. So what's a methodology? Well, I always go to the AmericanDictionary.com and the UK OxfordDictionaries.com to see if they make sense, because very often the American English definition might disagree with the UK English and might also disagree with the Australian English. So it looks like the first definition on dictionary.com agrees with the UK English. It's a system of methods used in a particular area of study or activity. So basically, it's a system of methods. It's a way of doing stuff. There's a chap from the 1930s in America called Mason Cooley who came up with a number of witty comments. And actually, I quite like this one because in many ways it describes what we're trying to achieve. A methodology gives those with no ideas something to do. In other words, a lot of the complexity of media delivery comes from having no standardized method for doing that complexity. So you have to employ really smart people to effectively do things that aren't too smart, because there's no methodology that allows you to do them with less qualified or cheaper people, or get those people with the brains doing better things, more creative things, inventing new things rather than just doing repetitive things over and over again. So methodology is all about defining ways of repeating a particular process or activity to get better business value. So let's put all that together. SOA helps you break the problem down into processes, and those processes help you cope with change. BPM allows you to implement and manage those services, but those services are all about fulfilling business requirements. If you put all of that together, you now have a BPM methodology. And if you want to read something a little bit more formal, when I did this presentation in the middle of 2015, Wikipedia had some very good text on business process management, but it's Wikipedia and they have a process for change that allows that definition to change. So go have a read, see what it looks like. So there's a couple of underlying assumptions that I'm going to use, which are kind of true at this phase of the development of the media industry. I'm going to assume that business metrics are improved by having improved automation and improved flexibility. So you can either do more stuff with the same people or more different stuff with the same people. And I'm also going to assume that the easiest way to automate is to use a software engine rather than just bringing more people in to manage the automation process. Those two assumptions are pretty true for most of the things that we do in the media industry today. So let's have a look at some common BPM phrases. We went through the SOA vocabulary. We'll go a little bit more quickly through the BPM vocabulary. These are the phases in which you develop your BPM methodology. So what do those mean? Well, first, there's the discover phase and then the formalize phase. And really, these are the two phases of BPM that take the most time and are most critical to getting it right. So to discover and formalize your business processes takes a lot of time because not many people actually truly understand how their business works unless they've been through this sort of process in the past. And anyone who's listening to me who's been through an ISO 9000 or an ISO 9001 process will understand just how difficult it is to take a medium or large organization and figure out what people actually do and what value they bring in and how the business actually works. How does what you do add value to the business you work in? Difficult task. And a scary task, because very often you discover that there are things you do in your business that make no sense. And often you discover there are things you should be doing in your business that nobody's actually doing. So the discover and formalize are the hard, difficult jobs. And if I'm a little cynical, it's the bit you get the management consultant in to do because it's too scary to do internally. But once you've done that, you can then implement those business processes to deliver the services that you've just defined. And very often that involves bringing in some software to do it in an automated fashion. Once you've implemented those processes, you then take the handbrake off and you then start to execute on those processes. And once you can execute on them, you can now monitor what's going on. And if you can monitor what's going on, you should be able to improve upon those processes. And then you repeat that loop while you're still in business. So BPM goes all the way from discovery through to the continual monitoring and operation. Now let's look at some BPM words. There's lots of words and lots of acronyms, and many people use them incorrectly and differently. So I'll choose the way that I interpret these words, which seems to be kind of in the mainstream. Let's start with ESB, the Enterprise Service Bus. So an ESB is a software architecture for designing and implementing and communicating between your different services in your SOA. So think about it as kind of a common connector that allows you to have the consumers and the producers of those services talk to each other without really knowing what's at the far side. So in the examples I've used before, you might have a FIMS-defined file movement service on the right-hand side, and you might have an ingest application or some other application that, or a restoration application that requires that service to move stuff around on the left-hand side, and the ESB connects things together. And there are quite a lot of ESBs out there on the marketplace. You can have open source ones like Mule, or you can go to Sony or IBM and go buy one of those. And you'll note that I've also marked here SOAP, REST, Genie, and Arnie. We'll talk about those in a second. So if ESB is the bus that connects everything together, what's BPMN? You know that BPM has grown an N now? Well, BPMN stands for Business Process Modeling Notation. And it's a standard graphical way of showing business processes that can generate a standardized XML for execution. So it's a bit like the flowcharts of the 1950s, with the added bonus that once you've defined these business processes, you can actually directly map those diagrams into an XML representation of those diagrams, put that XML into an engine, like a BPEL engine, Business Process Execution Language engine, and you can actually run it, and you can actually see those processes running in real time. And you find there's quite a few implementations of that. There's the activity engine, there's a thing called NoFlow, there's all sorts of ways of doing this. So I talked about BPEL. What's that? Well, BPEL, if you like, is the next level down. It's the Business Process Execution Language. It's a way of defining the interconnectivity of those processes in a way that you can pass metadata between the processes so that they have sufficient information to actually execute this. And once you can execute all the processes and execute multiple processes, you're now doing what's known as orchestration. You're orchestrating all of these processes and putting them together. So orchestration, which you've probably heard about, is the automated management of computer systems, often involving middleware, such as an enterprise service bus or a BPM engine. And this is kind of key for cloud functionality, because if you think about what you're trying to do in the cloud, you want to set up some business rules that will automatically scale out and generate new instances of your software based on the loading that you're trying to put into your system. And those rules are business specific. They're basically controlling your cost. And this orchestration is typically done in software and is typically done using, as I said, a standardized generic engine. And I did mention that I'd come back to these other technologies, these web service technologies, .NET, Java, JNI, RNI. These are all technologies that allow you to implement web services. So .NET is a Microsoft web framework that runs in all of Microsoft's languages. Java is a cross-platform language running in a virtual machine. And JNI is a way of escaping from that virtual machine to access the native machine. RNI just happens to be the same sort of thing as JNI, but nobody really uses it anymore. I put it in for completeness because you still see it floating around, especially in organizations that have a very strong Microsoft kernel. So whereas .NET, Java, and JNI are technologies for implementing web services, there are other technologies that talk about the interfaces to those web services like REST, SOAP, RPC, XML, RPC, and AJAX. So REST stands for Representational State Transfer, more of that later. SOAP used to stand for Simple Object Access Protocol, but it no longer does, an XML messaging format. RPC is a Remote Procedure Call. Do this over there. Okay, that's web services. XML RPC is kind of a safer way of doing RPC, more of that later. And AJAX is an asynchronous way that browsers can talk to a back-end system so that you don't have to refresh the web page all the time. And you see all of these words, all this language fitting together many times when people talk about BPM. And if you want to go and try a BPM engine or build one into your product or into your facility, there's lots of them about. There really are loads. Wikipedia, as usual, has quite a decent list, and there's quite a few people that maintain that list. Some ones that you'll come across, and I've put some links here in the presentation, which you should be able to click on if you go to our website and download this presentation. The IBM Business Process Manager. You can go to the site, you can pay a lot of money for that. You can pay a lot of money for the SAP Business Process Manager. You can pay a lot of money for the Oracle BPM. Those are all paid for products which you can buy, and effectively somebody else is writing them for money and you can run them in your organization. But there's also quite a lot of free BPM engines that you can just download and you can just use, and you can contribute to the projects by paying for support to the people that write and maintain and improve those particular engines. So the Activity engine is one that I know reasonably well, which is a Java BPM engine. Bonita, another one. JBPM, Signavio. Many of them have common roots, some common human beings between all the various projects, but their goal really is to define a generic business process management engine, typically programmed with a BPMN 2.0 front end that allows you to define your processes and then execute and monitor them. But there are other tools as well. Look at Mule. Mule is an enterprise service bus rather than the BPM. And by looking at the difference, for example, between Activity and Mule, you can start to see some of the overlaps and some of the differences between an enterprise service bus and a pure BPMN implementation. You can find Apache ODE. That's a business process execution language project rather than the BPMN project. And again, by looking at Apache ODE and comparing it with Activity, you can start to see some of the subtle differences between BPEL and BPMN. Then, of course, you can implement the principles and not use the standards. So there's quite a funky little zero programming flow manager called NoFlow, which runs in a language called JavaScript. That's kind of funky. It kind of does the same things, but it doesn't depend on any of the standards like BPMN, etc. So there's a lot of technology out there, but in reality, they're all trying to achieve the same things. They're trying to draw a picture like this and have that picture execute so that you can fulfill some sort of business process. So let's have a look at this in a little more detail. So here's your first grounder in business process modeling notation. The little circles that you see represent events. Often these trigger something. So a start event will trigger a process. So here is a process. It's actually a script task. The words task and process are often interchanged. And when we end with an end event. Now this event ending could trigger some other workflow. Here we've got something a little bit more complicated. So we've got a start event. We then go into a script process which validates an order. These lines represent sequence flow. So this happens, and then next in sequence is the complete order process. And you note there's a human, so this is a human process. So BPMN allows you to define processes which might be automated and run on a computer, or involves actual humans doing actual work. So the human gets all the data, does their process, and then when they finish their task, we go to the next thing in sequence, which in this case happens to be the end event. So let's put all of that together and look at something a little bit more complicated. Here we receive a loan request. So this comes in through some magic. There may be a whole new BPMN upstream that triggers the receive loan request workflow. First, we have a script process to do a credit check. That might be some external web service request. It might trigger some other workflow, who knows? The next in sequence is to then run the software which creates the loan request application. So this is an automated process. That's what the cogs mean. It then, next in sequence, goes to a human being who will evaluate that loan request. And you'll note that we have a boundary event here. So when that incoming request arrives at the human, a timer starts. And if that timer times out, in other words, the human hasn't completed the task in time, the request will be elevated to the manager. And in theory, the manager, who's lightly loaded and obviously on holiday most of the time, will do the work on behalf of that human, and one or other of those will finish first, and the loan will either be approved, in which case a human will process the request, or not approved, in which case an automated denial email will be sent out saying you're too poor to borrow money. Either way, whichever one of those you go through, you've then ended up here at the end event. Now this thing's known as a gateway, and the X means exclusive gateway. In other words, you can go up one path or the other, but not both. As opposed to a parallel gateway where you go into the gateway, and in a parallel gateway, all of the processes would be triggered when you go into that gateway. The other thing about BPMN is the ability to do hierarchy. So for example, here we've got a bug request workflow. We've divided visually the workflow up into pools. The pools are just annotation to make it visually clearer that the tasks are related to each other. We trigger when Jira, which is a bug tracking manager, has an issue being logged. So that's the start event. We log the issue in Jira, and then we go into this sub-process, which is initiated. There's a connectivity there, so that initiates the process. The developer tries to solve the Jira issue, test the provided solution, and if it's not working, it goes back again. It goes round and round and round the loop until eventually approves the fix. Again, note there's a timer here that if the Jira issue is not fixed in time, we go to the end event and tell the customer can't fix, won't fix, or whatever. So this is a way of modeling sub-processes, and by having these sub-processes defined, it gives you a much more elegant way of trying to put your processes together to build the services that you need to run your business. So we've done SOA, we've done BPM. Web services are actual technologies. And because you can find out lots of this written down, I'm going to spend a little bit less time on the technologies. Let's start with SOAP. All you need to know about SOAP is you've got to think envelopes and messages. So here you can see the XML of a SOAP request. You can see it's in the SOAP namespace. The SOAP namespace has a SOAP action. So that defines your namespace. Within the SOAP specification, there is specific headers that you want to send. Headers and the whole SOAP request are sent via the HTTP protocol. So here we're going to do a post request to that host with that sort of content, with that length, that's a definition that it's a SOAP action. Here's the XML body which defines what we're trying to do. We've defined the SOAP namespace. There's nothing in the header this time round. The body says get stock price with the parameter IBM. And we've defined a namespace here for the metadata, and that metadata helps you be strict about the XML for these particular parameters. So that's what you would send, and you get an XML back. Now, if you want to play with XML, there's an awesome tool called SOAP UI, which is free. You can download it. And if, for example, you wanted to figure out the SOAP requests available from a particular device, there's a language called WSDL, or Web Services Description Language. You can point SOAP UI at the device, and WSDL will allow you to explore all the different web services available to you. So, for example, if you take the Dalet Academy transcoder, you connect to port 8080 of that particular transcode, and you get the WSDL down. Suddenly, with SOAP UI, you can be programming the Amberfin transcoder automatically within seconds of SOAP UI connecting. It really is quite an awesome and very clever tool, and it's free. What about RESTful? RESTful is all about resources. RESTful stands for Representational State Transfer. You're trying to find out the state of a resource. So the representations is basically how do you consistently describe that resource? For a playout server, is it playing? Is it stopped? Is it recording? The messages within REST are all standardized. They're nearly always HTTP requests, and those HTTP requests talk about resources. Those resources are in the form of uniform resource identifiers, and that's usually the URL, some modification of the URL. So here we've got a RESTful request to some device. We're trying to find out about the users. We're trying to get information about user 123. So usually the URIs help you formulate an identifier of that particular resource. RESTful standardizes the interface. So if you do an HTTP GET request, you're reading. If you're doing a PUT request, you're updating. A POST request is creating something new. A delete request, well, you can figure that one out. And if an options request often gives you a list of which of these is supported. I've talked about making good stateless web services. So it's always good to formulate your web services in terms of get page 3 instead of get next page, because get next page requires the client and server both understanding what they mean by the word next. Using the URIs, you can link resources together. So typically it'll be of the format protocol, service name, resource type, resource ID. So service persons 1 is an identifying link to a resource using a URI as an identifier. And RESTful also uses the HTTP caching mechanism to help you know when to update stuff and when you don't actually have to ask the server again. So you can, the server can set the last modified HTTP response. The client can do an if modified bit of logic on the HTTP responses it has, and then the server can then say, nope, it's not been modified. So actually, this is a very cheap transaction as opposed to transferring tens, hundreds, or megabytes of XML that you didn't need to do because there's been no modifications. Discovering is often done by naming protocols or WADL, the Web Application Description Language. And very often, if you go to that API, you'll get back some WADL. So RESTful is kind of new. SOAP's a little bit older. They both have different strengths and weaknesses, which are too detailed to go into at the moment. Let's have a look at RPC. So RPC stands for Remote Procedure Call. Think verbs. Do this on that remote server. RPC, Remote Procedure Calls, have been around for a very long time. Think before the web. There are security issues. They're not very HTTP friendly if you're thinking about pure RPC. A pure RPC might be delete that file on that server. That's quite dangerous. It's got a different trust model to the way that we're thinking about firewalls and security and authentication with today's interweb. It's widely used on older IT equipment, and it still exists on your laptop now. If you're watching this on your laptop or your server or your PC, there's lots of RPC holes or opportunities for people to get into your server. Very often those are closed off without having good authentication, but they're still there for legacy reasons. A more secure version of RPC is XML RPC, where effectively there is a semi-standardized XML representation of the procedure call that you're trying to do. It's more friendly, it's more simple, you can put more firewalls up, but it's still an RPC. You're basically sending an XML command that says, do this on that server. So now that we know that we can speak the lingo, let's have a look at some real worked examples. Here we have a simple transcode process flow. So this is quite a low-level workflow. Let's have a look and see what sorts of things we do in a transcode process flow. Our start event is a watch folder trigger. We have to figure out what was in that watch folder, what triggered the event. So we'd analyze the media and get some metadata. That goes into an exclusive gateway. If it was 29 interlace, we go down here. If it was not 29 interlace, we go up here. So it's exclusive. We only do one of the two options. And basically what we're trying to figure out here is it in the right frame rate? Because if it's in the right frame rate, copy the resource to a combiner. And if it's not the right frame rate, transcode it and then put it into a combiner. The combiner puts some audio with the video, and then we do a QC, and we figure out whether or not we passed or failed. If we failed, we send an email. If we passed, we move the QC report to wherever we need to be, we move the asset report to wherever that needs to be, and then we end. So a very, very simple workflow explained in terms of triggers or events, processes, and gateways. When you select in a BPMN editor, and this is using the Amberfin platform, same true for the Dalet Galaxy workflow controller on the MAM. Select one of these and suddenly you can see what the inputs and outputs are and what metadata gets passed to and from each of the processes. And this metadata that comes along the sequence flow allows you to control how each one of these different processes actually gets executed. So it's a bit like a flow chart, but it's more sophisticated because we can identify the incoming and outgoing metadata, and we can actually run this and follow the logic as it goes through. So let's look at some typical high-level workflows. Now these are real examples from some of our real customers. So we've got a trigger. The media event takes place. Let's copy it to central storage and then in parallel do all of these different tasks in parallel. Let's create a proxy, let's create a mezzanine, let's extract the captions, and let's do a QC. All of those are taking place in parallel. Then when they're all finished, the QC result goes through the exclusive gateway, and we either delete everything we just did because it failed QC, or if we've passed in parallel, we then go through and we replicate to different sites, we move to long-term storage, and we archive stuff. So we do some work. That could have been a sub-process, but wasn't because it wasn't sophisticated enough and it doesn't get reused enough. And we basically are able to draw, using BPMN, some processes that deliver effectively an ingest service, because when we ingest, we do all of those things. Here's another one. Here we've got a start event. We do a track stack, which adds audio languages onto an existing asset. So this is an internationalization workflow. We get some field values. We can form the audios. We auto QC. Human reviews the QC. And depending on when we pass or fail, there's a fail going to an end event. And if we pass, we go through the pass workflow, where the QC then goes through an editorial review to make certain that the human in charge of editorial rather than technical QC is happy with it. And we then generate all the transmission IDs and the thing goes out for transmission. So what we're doing here is we're taking various processes and services and putting them together in different ways to define the way that this company's business works. And here's an even more complicated. It's just more of the same thing, but this is a compliance workflow where, again, a media event starts. We change the state of the check the state of the automatic QC. We test whether it complies. Again, pass or fail. If we fail, we go to purging the media. And then depending on the where the stuff's being sent, we might do audio processing or proxy creation, etc., etc., etc. So there's automated processes, there's human processes, and intermediate triggers that are being created. But all of these are reusable definitions of processes implemented with services that allow you to build your whole workflow. And here's another one where we're basically generating from a start event a whole bunch of multi-platform, high-level OTT deliverables. And it's important that this workflow is all about high level, because all of those workflows I showed you effectively run on a MAM, and they are sending instructions down to the transcoder which say, just make me this asset. But the transcoder itself has very good reason to break complicated things like transcode to carbon WMV into this very low-level set of process flows to try and simplify and reuse the technology that you've already created. So high level for workflows, low level for processes. And if you can split those two separately, you stand a better chance of having good reusable workflows. So, should you care about orchestration? Well, a successful business, cough, edit that out. Well, a successful business manages its processes, whether those processes are human or machine. Designing those processes involves thinking about change. And change means that you're thinking about the business benefit that that service will provide. So change leads to SOA principles. SOA principles leads to BPM methodologies. BPM methodologies use existing tools to develop and manage those processes to make your business better. There are a huge number of tools out there. They need adapting to what you want to do with them. They don't need reinventing. Now you know all the verbs and nouns. Form your own opinions. Come back to us and tell us A, what you think about the education, and B, what you think about our products. My name is Bruce Devlin. If you search Twitter or our blog for #BPM webinar, you might find some of the commentary that's already taken place in this webinar. But for now, I'll see you at the next one. Goodbye.